In this video, we're going to review the method of substitution when we solve differential equations. So how it works, so we're going to start with a differential equation of first order. And you know that any first order differential equation can be written in this form. That's what we normally call the normal form. So the idea is to kind of use a special substitution so that it is easy to integrate. So let's look at, so what we do in this case, like in general, we're going to pick the function fxy. So we're going to call that u, so u equal fxy, and then use like a regular substitution technique. So we find the derivatives and plug in and simplify. Sometimes we don't pick the whole function because that can be complicated. So in that case, we sometimes pick just a part of it. So we'll see what we mean by that when we solve problems. So the whole point is once you put the substitution, and it will be easy to integrate. So that's the only kind of suggestion. So we pick something so that it is easy to integrate. So let's look at the first problem. So as the first one, we have this one. So dy by dx equal x plus y. You know that actually we discuss a similar problem when we solve first order linear equations. And you can see that this is a first order linear equation because you can move the y term to the other side. You can do that. You can move this term to the other side. So that means it is a first order linear, so we can use the integrating factor method to find it. And you know that when you do the integrating factors, there are a lot of steps to do that. But here, let's see how we can use the substitution technique to solve this problem. So what we do, we're gonna pick, we pick the whole function in this case. We're gonna pick x plus y completely. So we're gonna call that is u. So this is how we start. This is how we do it. So we pick u equal x plus y, the whole function on the other side. And then what we do, we take derivatives. So we take the derivative with respect to x, because there are three variables here. So we take with respect to x. So when you do that, you get dy, du over dx on this side. And the first term going to give you 1. The second term going to give you dy over dx. And next what we can do, we can solve for this. And then we can substitute. So if you solve for that, you get dy over dx equal du over dx minus 1. So you can write this one as du over dx minus 1 if you bring that to the other side. Now we can substitute. So and then by substituting, dy by dx part is going to be du over dx minus 1, and then x plus y is u. So that's what you get. Now you will see that this is again first order linear, because you can see that you can move the u term to the other side, but we have a different technique now. So what we're going to do, we're going to add one to both sides first. So that means you can write it du over dx equal u plus 1, and then you can see this is separable now. So that means this equation like different types also, like first one is the first order, but once you move it, now it's separable. So this is separable. So we use the separation of variable technique to solve it. So what we do, we can divide by u plus 1 both sides. So we can write this one as du over u plus 1, and then move the dx to the other side, and then integrate both sides. So that is the idea. So because you can do this much quickly. So let's do that. And you know that when you integrate 1 over u plus 1, so you know that when you have a constant, it doesn't change the format of the answer. So that means this is simply going to give you ln u plus 1 absolute value equal, and then on the other side x plus c. So you had only one c to both sides. And then what you will do next is we will write this one as the exponential form, and we know the theory. So what it says that if you have ln a equal b, since the base is e, you can write a equal e to the b. So that's the idea. They are the same thing. So we can write the exponential form. So writing in the exponential form, we have u plus 1 absolute value equal e to the x plus c you can write this one as e to the x times e to the c, and then when you remove the absolute value sign, you know that you get the plus or minus term, and then we write ec first and then e to the x. And then what we do for simplicity, I'm going to call this one is just a, because it's just a constant, so we can call that a e to the x or c e to the x, like that. Okay, now what we do, we're going to substitute for u. So, and since u equal x plus y, we can substitute that. So you're going to get x plus y plus 1 equal aex. Now what we do, we're going to solve for y. So if you solve for y, you can write this one as aex minus x minus 4. So that is the answer for this problem. And you can see, compared to integrating by factors, actually this answer you can get much quickly. You can see those steps are not that difficult, because you get the answer very quickly here, like that, and then after that it's just the algebra part. So you can compare the two solutions and see which one is better. And in the comment section, you can write, what is your favorite way to do this, solve this one. And then after that, what we can do, we can use the initial condition to find a. So let's look at the next problem. Say we have dy by dx equal y minus 5x plus 3 to the 8th power plus 5. So what are you going to do? You're going to pick the whole function or part of it. So in this case, actually, we're going to pick only the inside function as u. So let's see how it's going to work. So we can say let u equal y minus 5x plus 3, and then we take the derivatives. So taking derivatives, you get u prime on the left side, and the other side is y prime minus 5. That's what you get. That means if you solve for y prime, you can see y prime is the u prime plus 5, and then by substituting on the left side you get u prime plus 5, and on the right side you get u to the 8 plus 5. And then you can see that 5 make a big difference, so this get cancelled out. So you simply get, if you write in the other form, it is simply du over dx on this side, and the other side u to the 8, and you can see this is a separable equation. So we move the terms and integrate, so we can write this one as du over u8 and the dx on the other side, and we can integrate both sides. So this is very easy to integrate using the power rule. So let's do that. So for that, what we can do, you can write this one as u to the negative 8 du. On the other side, you simply get x plus c. And then using the power rule, you can see that this side is simply u to the negative 7 over negative 7 equal x plus c. And if you multiply by negative 7, both sides, you can get u to the negative 7 equal negative 7x. Let's call this variable constant c1. So you're going to get negative 7c1, but you can call that just c for simplicity. You don't want to call it 7c1. Okay, now what we're going to do is we can flip this over, so it get u to the 7, and then it's going to be upside down. So I'm going to write this is c minus 7x. That's the whole reason why we can write like that, and then take the 7th root. So if you do the 7th root, you see that you get 1 over c minus 7x to the 7th root. And you can see that this is only valid when x, so this is valid when c, like x, in this case x, not equals to c over 7. So you have solved it for u. Now what we do, we substitute back from u. So we know the u equal y minus 5x plus 3. If you substitute that, so it is y minus 5x plus 3 equal this answer, which is c minus 7x to the cube root. Now we can solve for y like this. So y equal, move 5x to the other side, move 3 to the other side, and then we have this extra term, which is c minus 7x to the 7th root. So that's how you solve the problem using substitution method. See whether you can actually do this using any other technique. So that's like a kind of challenge. Okay, let's look at the next one. So as the next one, let's look at this problem. So dy by dx plus 10x equal square root of y plus 5x squared plus 1. And so what I'm going to do, I'm going to pick this inside function as the as u, and then take derivatives. You get y prime on the left side equal u prime equal, and then on the other side you get y prime plus, if you take the derivative you get 10x. So that means you can see that's exactly what you have on the left side. So you can substitute now. So the left side of the differential equations becomes u prime, which you can write as du by dx. And then on the other side what you have is simply u square root. U equal y plus 5x squared plus 1. Now you can see this is separable. So moving the variables around, and you can write this one as du over square root u equal dx, and integrate. This is just a power rule, so you can easily integrate. So you get 2 square root u if you use a power rule, because you can see that 1 over square root means u to the negative 1/2. So when you add 1 you get positive 1/2. When divided by 1/2 become 2, so that's what you get from the left side. On the other side you get x plus c. Now what we do, you can substitute. So we can substitute. Since u equal y plus 5x squared plus 1, you can write it like this, which can be solved for y. How you do that? First you divide by 2 and then square. And when you square this and simplify, you get this one as the final answer. So if you know a initial condition, then you can find c from this one. Okay, so let's look at the next one. So we have 3 y squared y prime plus 3 equal y cube plus x. So and you see that here we have used a chain rule. Because of that term, actually what we can do, we're going to pick this one as the u for these problems. So let's see how things going to turn out after that. And then we're going to differentiate. On the left side you get y prime. On the other side, by the chain rule, you are trying to take derivative with respect to x. So it is 3y squared, that's the first term, and then you have to multiply by the derivative of y, which is y prime. And then you can see that's exactly what you have on the left side. So we can substitute now. On the left side, it is going to be u prime plus 3. On the other side, it is u plus x. Now you can see this is not separable, but you can write this one in this form. You can move the u term to this side, and you can move 3 to the other side. So now this is first order linear, and we know how to solve these kind of ones, and you can see there's a link in the description to learn about how to do these things. Okay, so we use the standard technique. So we're going to find the integrating factor, which is, so you get e to the negative x as the so this is p, so e to the negative x as the integrating factor. Now you're going to multiply by that and integrate. And you know, because of the choice of the integrating factor, the left side simply becomes d by dx, the e to the negative x times u. And you can verify that if you use the product rule, that's exactly what you get. And then on the other side, you have e to the negative x, x minus 3. Now what we do, we can integrate. The derivative going to cancel out, so you get e to the negative x u on this side, and the other side you have the integral of e to the negative x x minus 3 dx. For that, so you know that this is a integration by parts problem. So for that we use a shortcut, the DI method, and if you don't know the DI method, you can find the link in the description for that. So what we pick, we're gonna pick the one that is easy to take the derivative on this side, and the other one is the integral one. And you take the derivative, you get 1, integral you get negative x, the derivative you get 0, integral you get negative x, and then you multiply across the diagonal starting with the plus sign and the minus sign switch. So that means your answer is the first diagonal product, which is negative. You can see e to the, so x minus 3, e to the negative x, that's the first term. The second term is again negative, e to the negative x, and we add a c here. And then what we do, we need to isolate the u term, so you can multiply by e to the x. When you do that, you get u on this side, and you can see e to the negative x term get cancelled out. So you get, so I'm going to write the c term first. So you get cex, that's a positive term. I normally write the positive term first. And then you get, first one you get x minus 3. The next one you get minus 1. And you can simplify these. And also you can substitute for u, because you know that it is y cube. So you can put it there. So it is cex. If you simplify, you get minus x plus 2. Now what we do, we can take the cube root to get the final answer. So y equal simply the cube root of this one, cex minus x plus 2. So this is how you solve the problem using the substitution technique for this one. And we use a special substitution here, which was u equal y cube. So next, let's look at two different type of problems that you need to kind of remember. So let's look at that next. As the next one, we can look at this one. So dy by dx equal y plus 3x plus 7 to the second power square. So what we can do for this one, we can try this inside function as u. So, and when you take the derivative, you get this one. You get dy du by dx on the left side, and on the right side you get dy over dx plus 3. That's what you get. So that means this tells you that dy over dx equal du by dx minus 3. And when you substitute, on the left side you get du over dx minus 3. On the right side you get u squared. And then what you can do, you can add a 3 to both sides, and you can write this one like this. So du by dx equal u squared plus 3. And then what you can do, this is separable now. So you can move the terms around, and you can write this one as du over u squared plus 3 equal dx. And we can integrate both sides, and you can see the left side is simply, right side is simply x plus c. What about the left side? Left side has the special form that we normally talk about, those two special integrals. So we use this form. So let's recall this one. We know this result from calculus. 1 over x squared plus a squared equal 1 over a tan inverse x over a plus c. This will be, there's a plus sign here. So if you use that now, we can write the answer like this, which can be written as, so in this case you can see that a equal square root 3. So you can plug in that, and you can write the answer like this now. So because of that, you can write the equation like this. You can equate this one with x plus c. So we can write it like this. And now what we can do, actually we can multiply by square root 3 both sides to remove that. So we get this one. For our algebra simplicity, we can just call this as square root 3x plus c. Those two c's are not the same, because it doesn't matter, it's just a number. Okay, now what we do, you can take the tan of both sides to simplify. And otherwise, like, this is a good answer, but we can take tan of both sides. So we can write it like this. We have u over square root 3 equal tan square root 3x plus c. Now we're going to multiply by square root 3 again to isolate u. And next, what we can do, we can substitute for u, because we know that u equal y plus 3x plus 7, and which is equals to tan term. Next, what we can do, we can isolate y. So we can move the 3x plus 7 to the other side. So this is the explicit solution for the for this problem. Okay, so here you can see that we use the special form, the tan inverse form. Okay, now let's look at another one that is the other form. So let's say we have this one, dy by dx equal y minus 2x plus 3 squared plus 1. This problem is very similar to the previous one. We have the extra term here, and then again we're going to pick inside function as the u, and then take in derivative, we get du over dx equal dy over dx minus 2. This, if you isolate dy by dx, you get this one. Now we can substitute all of these into the equation. So the left side becomes du over dx plus 2. The right side becomes u squared, because u equal y minus 2x plus 3 plus 1. Now if you subtract 2 from both sides, you can write this one as du over dx equal u squared minus 1, and you can see this is separable, so you can divide and integrate. So you can see how to integrate something like this. We know that if because since you can easily factor the bottom term, we use partial fractions to integrate. But this one has a special format because it's like a u squared minus a squared, or it's like x squared minus a squared. So we can use this special formula for this one to save time. You get this one when we have a plus sign, and you get this when you have a minus sign. And if you are a Calc 2 student, don't try to use this directly, but remember this formula, then you can see that if you make a mistake, you can check that. But for other courses, actually you can use this directly, but not for Calc 2 students, because here like your professor may be checking that whether you know this. So, but still, you should get the same answer. But for other advanced courses, you can directly use this one. For physics, engineering, this is like a very common formula that you can use. Okay, so let's use these two. This is the second one, and we can write the solution like this. So we have du over u squared minus 1. In this case, a equal 1. So you can clearly see that a equal 1. So if you plug in that to the formula, so you can see that you get 1 over 2 natural log u minus 1 u plus 1 equal on the other side x plus c. Then you can multiply by 2 and remove the absolute sign. You get so plus or minus for that. Then when you remove the absolute sign, you get plus or minus. And you can see, you can just simply call this term it's just a constant. You can just call it a. Or c. So then you can write this one as simply c e to the 2x. Now what we do, we're going to cross multiply and solve for u. When you cross multiply, you get this one. And then we bring all the u terms to one side and the other terms to the other side and factor. And then by dividing, now since u equal y minus 2x plus 3, we can substitute that. And then finally you can solve for y. We can move the other two terms to the other side. Also, there's something very interesting going on here. In the long run, when x is large, you can see these two terms getting very close to each other. So because of that, what does matter is those two terms. So that means that the fraction actually reach a -1. So that means what will happen in the long run when x is getting larger, this solution actually reach 2x minus 4. So as x goes to infinity. See how you can actually do that. Okay, so now what you can do, you can try these problems as practice problems. Solve. So you see that those three have only difference is the constant, and you can see that you get three different answers, three different techniques for these three. First one, just go with a regular separation, and for the other two, you can use these shortcut formulas. And one is a tan inverse, one is a natural log. And also you can try these two. This one is the same problem as the part A, but use this special substitution. We pick the whole thing this time and see what's going to happen. We do that. So let's do it. As the last one, try this. For this one, try this special substitution. What we can do, we're going to pick this part completely as the U for this one. And if you know the answer to these questions, you can put that in the comment section. So we learned that we can use several different techniques sometimes. So sometimes we can pick the whole function. Sometimes we pick just a part of it so that it is easy to integrate. Okay, so thank you so much for watching.